Hello everyone, welcome back. Kindly pardon the delay in putting up the follow-up video. I want to believe that from now on you'll be having a minimum of one video per week to help you in your math journey. Alright, let's get straight into business. So we'll be doing a few questions on set theory just to help your understanding, and these are word problems, okay? Alright. Let's see. So the first question says, a survey was conducted with a group of teenagers to see how many liked going to the cinema and ice skating. The results are shown in the Venn diagram. Determine the number of teenagers, A, B, C, D, E. Those are the questions. The number of teenagers in the group who like going to the cinema, who like at least one of these activities, who only like ice skating, who do not like going ice skating. So this is the Venn diagram right here. C stands for the cinema, I stands for ice skating. The number 6 are those who love going to the cinema only, while the number 14 stands for the group of teenagers who love going to both the cinema and ice skating. 5 stands for those who love ice skating only, and one person doesn't like either the cinema or going for ice skating. So that's the information we have here. So to determine the number of teenagers in a group, that's quite easy. Just add everything up. Add the number, the whole number in the Venn diagram. So that will be 1 plus 6, 7, 7 plus 14, 21, 21 plus 5, 26. So we have 26 teenagers in the group. 26. All right, now B says those who like going to, the number of teenagers who like going to the cinema. The number of teenagers who like going to the cinema, so that will be everything in the cinema circle, okay? 6 stands for those who like going to the cinema alone. They don't like any other thing apart from the cinema. While 14, they like the cinema and ice skating too. So they also like the cinema, but something else is also added to what they like. So that's why we are taking everything in the circle, because the question says those who like going to the cinema. If the question had said, or if the question was the teenagers who like going to the cinema alone or the cinema only, would have taken 6. But it didn't give that exception or that exact request, those who like going to the cinema only. It just said those who like going to the cinema. So we'll take both 6 and 14, and that would give us 20. Okay, now the number of teenagers who like at least one of these activities. This is the key word, at least. So they might like more than one, but they must like a minimum of 1. So all you need to do is to add everything up. Everyone here likes at least one activity. Those here like 2. This like people here like 1. Here like 1. This likes none. So we're not going to add this to the mix. So that will be 6 plus 14, 20. 20 plus 5, that's 25. So 25 teenagers like at least one of these activities. Now, the number of teenagers who only like ice skating. Now we have this keyword here, only. So we're going to pick this number here, 5, because these are the number of teenagers that only like ice skating. We're not going to pick 14. Here in 14, we have the 14 teenagers here like ice skating and cinema. But we're looking for those who like ice skating only, nothing added to that. So that's 5, sorry. So we're going to write 5 for question 1D. 5 teenagers like ice skating only. And the teenagers who do not like going ice skating, we have, that will be every teenager that's not in this circle. Okay, every teenager not in this circle. So that will be 6 plus 1, and that will be 7 teenagers. All right, so that's that for number 1. Number 2, the Venn diagram alongside describes the member participation of an outdoor adventure club in rock climbing, R, right here, and orienteering, O, right here. Determine the number of members in the club. All you need to do is to add all the numbers here. Okay, the number of members in the club. This Venn diagram talks about all the members in the club. So you add those in each circle and those that are not even doing any of the club activities. So that will be 7 plus 16, 23. 23 plus 11, that will be 34. 34 plus 14, that will be 48. I want to be sure I'm correct. Let's see. We'll add again. 7 plus 16, that's 23. Yes, 23 plus 11, That's 44. 44 plus 14 plus 14, that's 58. Wow, thank God I added again. So we have 58 club members. So this will be 58 club members. All right. Determine the number of members who go rock climbing. So everything in the rock climbing circle will be for rock climbing. Remember, it wasn't stated rock climbing only. If it was rock climbing only, we would have picked this number 16. But the question says who go rock climbing. Okay, so that will be 16 plus 11, and that would give us 27. So 27 members go rock climbing. Those who do not go orienteering, everything outside the orienteering circle. So everything outside here, that will be 16 plus 7. 16 plus 7, that's 23. 23. Now those who rock climb but do not orienteer, the rock climb but do not orienteer. So that will be 16 alone. 16. Why is it 16? Because those who rock climb but do not orienteer is another way of saying those who rock climb alone, or those who rock climb only. All right, so that's 16. And then E says those who do exactly one of these activities. Now this is different from number 1C. It's different from what we have here. It says those who do exactly, not at least. At least and exactly are different. At least is minimum. Exactly means what it is, exactly. So those who do exactly one activity. That will be 16 plus 14. They do exactly one activities. 11, that's the number in the middle, do two activities. 11 members do two activities, but 16 members do rock climbing only. 14 members do orienteering only. So 16 plus 14, that's 30. So 30 members do exactly one of the activities. All right, I hope you got 1 and 2. Let's move on to 3. Okay, a team of 24 swimmers took part in the competition. 15 competed in freestyle, 11 competed in backstroke, and 6 competed in both of these strokes. Display this information on a Venn diagram and hence determine the number of swimmers who competed in backstroke, but not freestyle, at least one of these strokes, freestyle but not backstroke, neither stroke, exactly one of the strokes. So first of all, we'll draw a Venn diagram. I always say anytime, even if you're not asked to draw a Venn diagram, if you're given a word problem in set theory, I would always advise my student to draw a Venn diagram to analyze the information given. And if you draw your Venn diagram accurately, you'll get your answers easily. Okay? Kindly pardon my Venn diagram. It might not be that perfect, but you understand what we need to do. Okay? So the universal set, what are the total number? I like putting the total number outside. So if I need to add up to confirm the information I have, I'll know if I'm on the right track. So you can put your 24 here and your U somewhere else, or if it's necessary. Let me just put my U here. Okay, that's universal set. All right, so everything in here should add up to 24. Now, 15 competed in freestyle, 11 in backstroke, 6 competed in both of the stroke. I love starting with those in the middle because I might need to work out the number here and the number here. So I'm sure that 6 people participated in the 2 activities. Oh, I've not labeled my sets. So this first circle will be freestyle F, those who competed in freestyle, while the second circle will be those who competed in backstroke. Now, 6 of the swimmers competed in both of them. Now, how many swimmers competed in freestyle? That would be 15 minus 6. Why is it 15 minus 6? Some of you might ask. Why don't you just put 15? Because we were told that 15 competed in freestyle. Part of this 15 will be those who competed in both. If the information had said 15 competed in freestyle only, I could put my 15 here because I know that 15 stands for freestyle only. But it didn't say so. It says 15 competed in freestyle. That means some people might have competed in freestyle and also backstroke. So that's why I have to subtract the 6. The 6 swimmers who competed in both, I have to subtract the 6, that number 6, from 15. So I'll know those who did freestyle only. 15 minus 6 will give us 9. If I add the 2, I still have 15. So if I'm asked how many people competed in freestyle, that'll be 9 plus 6, 15. 15 people. How many people competed in freestyle only? That'll be 9. I hope it's making sense to you. All right, we move on. We'll do the same thing for backstroke. 11 people competed in backstroke, fine. How many people competed in backstroke only? That would be 11 minus those who competed in both. 11 minus 6, that's 5. So this is 5. 5 people competed in backstroke only. 5 plus 6, 11 people competed in backstroke. And then do we have any who didn't compete in freestyle? No, backstroke. How do we know? Add up this number. If it adds up to 24, that means everybody competed in either freestyle or backstroke or both. But if we have a remainder, that would be the number of people who did not compete in freestyle, nor did they compete in backstroke. So let's add it up. 9 plus 6, 15. 15 plus 5, 20. 20, yet we have 24 swimmers who took part in the competition. So we have 4 remaining. So those 4 would be outside. 4 of them did not partake in the freestyle or backstroke competition. So now we can answer our questions easily. Determine the number of swimmers who competed in backstroke but not freestyle. Backstroke but not freestyle. So this is backstroke, but they didn't compete in freestyle. That's another way of saying the number of swimmers who competed in backstroke only, and that's just 5 of them. Okay, 5. Now B says at least one of the strokes, a minimum of one of the strokes. That will be 9 plus 6 plus 5. Okay, a minimum of one of the games or one of the strokes, freestyle or backstroke. So that will be 20 of them. 9 plus 6, 15. 15 plus 5, 20 swimmers. C says freestyle but not backstroke. We have it right here. That's 9. Freestyle only, 9 swimmers. D says neither stroke. We have it outside there. Outside of the 2 sets, that's 4. And then exactly one of the strokes, that means freestyle alone and backstroke alone, that's 9 plus 5, and that's 14 swimmers. So you see how easy it is to get your answers when you draw your Venn diagram. That's why I always advise my students, whenever they're given a question, a word problem in sets, they should start with their Venn diagram, even if they are not told to do that in instruction. Okay, so let's go on to the last question for this video. In a building with 58 apartments, 45 households have children, 19 have pets, and 5 have neither children nor pets. Draw a Venn diagram to display this information and hence determine the number of households which have the following, or which will satisfy the following questions. So let's first of all draw a Venn diagram and then we'll go to each of the questions. Like I said earlier, you'll pardon my drawing. I'm not an art person. The main thing is to get the information across and get our answers right. Okay, so we draw the first circle. The first circle represents households that have children, and then the second circle represents households that have pets. So we'll name this first set children and the second one pets. Okay, so we have 58 in total. That's the number in the universal set. 58. I think I need to ensure that this really looks like a 5, or some people won't think it's to be 6. Okay, so that should look like a 58. Okay, all right, that's good. All right, so I first of all love to start with those who have both, if we're dealing with 2 sets, those who have both. So let's see if we can get that in the question. 45 have children, 19 have pets, 5 have neither children nor pets. Okay, we're not given that the number of those who have both, so we'll have to figure out that ourselves. So let's put it as X. We'll figure that out. So we don't know that yet, but we know that 5 have neither, so 5 can stay outside. Now 45 households have children. Remember what I said, if you don't see alone or only, that means you have the number of those who do both embedded inside that number. Okay, that means this 45 households that have children, some of them would also have pets, children and pets. Okay, so it's not just children only, because that was not stated here. So this won't just be 45, this will be 45 minus X, so that we don't have repetition of the same number. The number right here, we don't have it repeated right here. Okay, so this is 45 minus X right here, and this will do the same thing here too. This would be 19 that have pets minus X. So we know those who have pets alone. Those who have pets only will be here. Those who have both children and pets will be here. Those who have children only will be here. Okay, so we don't mix up the numbers. Now, if we add everything in this rectangle, it should give us 58. And that's how we'll get our answer. So let's work that out right here. I'll start with the number outside. 5 plus 45 minus x plus x plus 19 minus x. Everything is equal to what? 58. Okay. All right. Now, this is minus x plus x. They'll cancel each other. X minus x cancels each other out. So what are we left with? We're left with 5 plus 45. I think I'm going to add them just to maximize the space here. 5 plus 45 is 50. 50 plus 19 minus x is equal to 58. So we go on adding. 50 plus 19, that's 69. 69 minus x is equal to 58. So that means 69 minus 58 is equal to x. That means our x is equal to what now? What's 69 minus 58? That's going to be 11. Yes, 11. X is equal to 11. All right, I'm just looking over it to be very sure I got my answers right. So x is equal to 11. Now we can substitute right here, okay? So let's go ahead and substitute. So this will be 11. And this will be 45 minus 11. Okay, I have to correct that. And this will be 19 minus 11. All right, so let's go. Let me first of all close this up. So I know this is 11. This is 45 minus 11. And that will be 34. This is 19 minus 11. And that will be 8. So now we can answer our questions right here. How many households do not have children? That means all the households outside the children's circle. That'll be 5 plus 8, and that'll be 13. 13 households. How many households have children or pets or both? Have children or pets or both? That'll be 34 plus 11 plus 8. First of all, okay, let's answer this and I'll go back to what just came to my mind. 34 plus 11, that is 45. 45 plus 8, that is 53. So 53 households have children or pets or both. Now, to confirm what came to my mind earlier, to confirm that all the data we have here is actually correct, you add up everything here and see if it's going to give you the total number, 58 apartments, okay? So what's 34 plus 5? That's 39. 39 plus 11, that is 40. 39 plus 11, sorry, that is 50. 50 plus 8, 58. So you see we have the accurate information here. So we move on. That you should do before you begin to answer questions, please. Just to be sure you have the accurate data here. If you don't, you go back to your workings and see where you missed it. So how many apartments have children or pets but not both? Have children, have pets, but not both. So 11 will be out of the picture. That would be 34 plus 8, and that would give you 42. So 42 apartments have that. And then how many apartments have pets but not children? That's pets alone, and that will be 8 apartments. 8 apartments. And then how many apartments have children but not pets? That's children alone, and that will be 34 apartments. So this is where we'll call it a day. We'll be stopping in this video. I hope you enjoyed the 4 questions we worked out. If you need more questions, or if you need to watch more videos on this, I'll put a link to my website where we have like about 8 more questions there about on set theory, and then you can just enjoy watching it and learn from that. Okay, so thanks for watching. Hoping to see you next week in our next video. Bye bye.